So here we have the parts all cut out. I've already assembled the knob, but I'll put some photographs and do a voiceover how to assemble that, but it's quite easy. I was experimenting in this hopefully last revision on this engraving part, but I'll cover that in another video. If, like mine, your engraving has come out a bit sort of valid and troughs, don't worry about that. You can just get a bit of sandpaper or a file and just smooth that out. I might even try just using a craft knife. You can see I got valleys and troughs in here. I was experimenting with my air assist in changing the pressures and volume of air on this part while engraving it. So none of my time is wasted. I'm always experimenting. But this one, I'm not sure whether my experiment has failed or it's just the glue in this particular sheet of MDF that has caused this issue. This doesn't have to be perfectly smooth. You just need a slight recess. You just need a slight recess, and you can see that, and that will become apparent why when we assemble this into the laser. So that's got over that little issue.
So this is not rocket science at all. So you put the 3 spacers on the bolt, put some glue in between the parts and glue them together. Here I've slid the bolt through from the back side to align them. Then put some glue in between the plates and glue the middle spacer plate on first, the one with the non-markings on. Then glue the one with the marking on the top, clamp it up and let it dry. It's as simple as that. Then all I did was run a file or some sandpaper around the flats at the top and the bottom just to make it feel nicer on your fingers.
So what we're going to do first of all is cover the knob, and once the knob is assembled, just get a round file or a piece of sandpaper and just round the top and the bottom, so when you're putting your fingers on there it just feels nice, which it does. So make sure to do a dry fit. So what you're going to do, this is we'll do the front, because you should find the front has a little more or a little less tolerance, and I did mess up this cut file, so I've had to cut this extra slot out with a craft knife. That's why you can see white in there, but that's all part of R&D. So all you're going to do is make sure that the top part fits in there, and it is going to be a snug fit, well it is for me, and then this part slides in the top. So that's fitting in there. Going to take that out again because we need to assemble the sides first on that. Again, I do recommend that you have a set of needle files. So set of files like these. They come in different shapes, at round, flat, curved, and a square one, and I find the square one is particularly useful, that if you've got any slots that are a little bit too tight, look, you can just see it fits in there. Just a couple of light rubs like that on both, and it makes it fit a lot better. So next thing you're going to dry fit is to make sure the sides go on, so the sides go in like that, like so, and then the tabs or the spacers, you can push these in from the back. It's difficult with the camera in the way, like so, and you should find the back, it has slightly more tolerance. So that slips through there, because it makes assembling the 2 components a lot easier. So what we're going to do first of all is I'm going to glue all the tabs in the front. So this is the front, so we're going to lay the front down. I'm going to put some glue in all these tabs, and then I'm going to press in that part there. Now I've got my glue bottle, so I'm just going to put some glue in these tabs. Then I'm going to lay it down with the cutout on the desk and push the spacers in. Now it's important that the spacers are flush with the front. You don't want them protruding past the front of the assembly, because that's going to stop the laser from going up and down properly. Yep, that's looking good, so I'm just going to clean that off just with a damp cloth. Clean up the working area. Clean off that so it doesn't stick to the desk. Then I'm going to pop that down there, press down. Just let those go off, just double checking again that they are flush with the front. Give that 10 minutes to go off, and we can continue with the top part. So the top part is these two parts and these two parts. So you're gonna need the bolt. So this is the bolt we're going to use to secure it, and it just helps with alignment. So we are going to check that these parts fit in here first, which they do. So let's just glue these on. And the hole goes to the front. Well, you don't know what the front is. The hole goes to where the cutout is, and the cutout is for the laser control wire to be secured. So get that one there, a little bit of glue on in between the two. Push them down, clean off your squeeze out. Clean out the hole. And now we can glue. You're going to need your bolt and the nut. Find the nut, because that will help clamp the two parts together. So we're going to put a bit of glue on here now. Then align the two cutouts together. You can push the bolt through. And get a couple of clamps just on that to clamp it together. I don't think I've got another small clamp, so I can get another big clamp. Check for any squeeze out, and that's good. So that's just drying that one. When you're looking for your micro clamps, you can't find one, can you? Let me get another big clamp on that. So I'm happy with my alignments. I've taken out the bolt, and put 2 big clamps on there, just clean out the squeeze out. Put that to one side. So now we can prepare the shelf. So this is a little bit tricky, but you can see we've got offset hole, and that will become clear once we get it assembled. So the offset hole go to the right hand side. So this is the front, this is the panel, top panel, and it goes over to the right hand side. So I've checked that it all fits together dry. So what we're going to do, I'm going to show you this dry. We're going to put some glue in all the holes. We're going to offer this one up and get it started, and leave a gap. Oh, leave a gap here, because now what we need excuse me, now what we need to do is glue these bits on both sides, and then push it all together into all the slots. So let me do that. So we're going to put a bit of glue in between these. Put them together. Then I'm going to put some glue in the slots. So I add these 2 bits in. Get some glue on these parts. And then push it all together. So just making sure you've got no gaps. Okay, so obviously you've got some squeeze out. Find something you can gently tap. Not really necessary. Okay, so that looks good. Just doing a bit of clean up now. Just going to get a clamp on that, give that 10 minutes to go off. While it's going off, just continue with the cleanup. Making sure to clean the hole. Clean the rear tabs because you don't want any glue on those at the moment. Sorry, clean the rear tabs. So that's all looking good. So the next part is, once that's gone off, I'm just going to pause the video here for 10 minutes waiting for that glue to go off, and I'll come back. So while we're waiting for the parts to go off, you now need to remove the laser from your machine. Now you can see my laser looks a little bit different from yours. I've got the smooth slider in, but when you're taking off the white cable, get your fingernail underneath the white plug that is on the end of the lead and push up. I'm just using this hand just to hold the cable, but I'm pushing, all the force is with my fingernail, and that's off. So now you would remove your laser. Now mine's a lot easier because all I've got to do is undo 2 bolts at the front. You're going to have the 2 stupid little screws at the back to deal with, but this smooth slider does away with them. Now that's my laser off, ready for maintenance. So I would highly recommend you look at this video smooth slider. You can see it covers up the slots where the 2 stupid bolts go, and by the time you've got this mechanism on, you may not even need the 2 screws at the back, because with the smooth slider you certainly don't need them. Right, this is, I can't remember what version this is, but this is version 5. My version 5 here, you'll notice a hole is in the middle. Now in a second you're going to find out why I offset it. So let me take that apart while we're waiting for the glue to go off. So it's much easier to lay it on the desk when you're taking off these screws. So it's much easier to lay it on something when you're taking off these screws. Now you're just going to have the clear transparent piece of acrylic on the top. So that's the part you need to remove. And you're hopefully used to this because you should be doing maintenance on your laser. So I'm hopefully not telling you how to suck eggs. But I do want to, while this is apart, take a photograph of the fan, because I have an idea what I can do with the fan. So I'm going to take all that apart. Now you can see this one, you might be able to see that I've filed down the bolt on this one, because this is the middle position of the laser. And what happens is, be careful not to lose any of your spacers. What happens is that bolt is very close, slightly offset to that capacitor. So the reason I've now in my latest design offset where the bolt goes is it moves it away from that capacitor and gets it more over here. Now let me just record on video so I don't forget details of this fan. So if I put it down there, the camera should focus. So I've captured that. 12 volt, 1.2 amps, and the number is just, I think that's a standard 40-20 fan, but I'm going to do some research into that. Right, so where are we? Where is the top part? Still gluing, so that should be fine by now. So just going to do a bit of clean up on the squeeze out. Just left it a little bit too long, it's just gone slightly hard, but that's good. Just need to do a bit on there. Okay, so you need to put your, I'm going to take this nut and bolt off. No, I can use this one. So put your bolt in. If you're an American or not in Europe, you don't have metric fittings, you can just adjust that hexagon hole to fit your bolts, whatever you can find available in your local hardware store. So now just put the nut on, and the nut's here purely to stop the bolt falling out. I did think about gluing it in at one stage, but it's better if we clamp the two parts with a nut. Just going to nip that up with a spanner. So there we have it. Now when you're assembling it, don't be a donut like I did in a few of my revisions. The slot there goes where the cable's going. So the way I found easiest is push the bolts through, put the 4 long spacers on, making sure, Andy, the slot is where the cable's going. Then it's a bit awkward because the camera's in the way. Going to slide it on the printed circuit board. Then there we go. Slide the bolts down, turn the laser back on so it's on its flat back, it's easier. Now just make sure that the power wires to the laser module sit in this slot. As you can see, there's a slot there. Make sure they line up nicely before you start bolting the fan in. So there you go. Then gently, and that's it. So these recesses should be about 1 mil, 1.5 mil is fine. So that's just to allow the screws to grab a bit more than they would do without the recess being there. Now things are looking good, so we can put that to one side. Now while we're here, you can just see on this laser these wires here are pretty flush, but sometimes they stick proud of this PCB and the fan housing. So that is why there is a recess that we engraved on this part, just to make sure that the wires, when they're going up and down, do not become snagged on this frame that we're building. Right, so we put the laser to one side. Now time to assemble this onto there. I did make the tolerance on this part slightly bigger than on the front to ease it in, so you can just make sure everything is aligning. Now to me that's going to go in. I might, because I've got some dried glue, just on a couple of these tongues, just make sure that that's not going to interfere with the fitment. Okay, so let's go for it. Now once you get the parts aligned like that, you can put it on the desk and push down where the tabs are and get it together. Then once we get it stuck together, we're going to lay it in on the once we get it glued together, and before the glue goes off, we're going to slip it down on there and press the parts together. Now if you've changed your tab distance to the thickness of the material, I had to change my file to 3.1 mil. If you've got 3.15, 3.2, you can change your tabs to fit. So let me put some glue in these. So let me put some glue in these. And as you can see, I'm not being too worried about squeeze out on this part here. There's glue in all the parts, so hopefully on camera this is going to go in nicely. So I'm pressing down where the tabs are, so I don't, that one's a bit, I'm just going to get a hammer. Can't find my hammer, I'm just gonna this one. Okay, so now while the glue is still going off, slide this on here, and when you're pushing it down hard, support the bottom of the frame so you're not going to bend your profile. So that's good. So now I'm going to lift it off, and you'll notice you'll get a bit of glue on there. You can just wipe that off. But what that is proving to me is that the parts fit together. So then if you've got any glue, if you've got any glue squeeze out, you can just get a piece of material, just rub it up in there, and it will get rid of any glue. So that's it. So you'll find next time that you go to fit that on there, so I'm gripping the bottom of the back plate, pressing down, and that's it, fitted. So nice snug firm fit. And now let's move on to the exciting part and mount the laser onto this fine focus. So I'm going to have to now move, or I can do it like this. I'm going to cheat, but you can either remove your honeycomb bed or slip that up there. I think I've got a bit of glue in that hole, so just with a spare bolt, just going to work my bolt backwards and forwards. Slip that up there. Now you can see, hopefully, that when the laser is up in its fullest position, where the top of the fan is the PCB and our top cover, you can see that where the wires are, which is just below the circuit board, the wires are in this engraved location. So now I'm going to hold that all together, pop it on, and just leave it loose for the time being. Now we've assembled the handle, so we can just screw that on. Just to get the laser off the honeycomb bed. Hey, looking good. So now if you've got the two stupid screws at the back, you're going to have to put those back in. I've got the smooth slider, so I'm just going to, oh, I've lost the washer. Just going to put my two bolts in at the front. I have got a video on the smooth slider. I'll put it in the description or on the screen so you can take a look. It does make it so much easier to do maintenance, and you're more likely to take your laser off to do the maintenance because you're not putting your head inside your enclosure to be able to get your laser off. Anyway, that's it. That is the smooth slider fitted. So with the bolts undone, you can now see it's going up and down, and I've already tested the slider. That one turn was 70.75 millimeters. So if we put a piece of material on here, you have to come around this side, and if I drop it down, let's do 23 mil. So that's 23 mil. So let's do half a turn, one turn. In actual fact, that's near a half a mil. So anywhere between half a mil and 3/4 of a mil is one turn. But now you can see that the laser is held firm. So I'll be interested to know, those that you do it, you may not need this smooth slider because the laser is held with the bolts here. So now we've got a third position of contact, which is keeping the laser in its perpendicular position to the workpiece. You may not need this smooth slider. This smooth slider was invented some months ago, but that's it. That is the smooth slider in operation, and I'm finally happy with the design as long as the cable goes in. I haven't checked that, so let's wind it all the way down. And remember that once you focus, just to do your nuts back up to keep it in position. So I'm just going to put the cable back in. Perfect. Now, with the cable securing device, you'll see it's angled at the top. So I've got hot glue. If I take that out again, using my finger now to get it out. I put hot glue around this assembly before I invented this to give the cable more security on the white plug. But this is slightly angled, and the idea being is if it's angled too much to the left, you can always just file it down a bit to get your cable in nicely. So the cable goes in there. Press it all the way down, and then you get a cable tie in that hole, wrap it round, and it prevents any strain on the cable because the laser will fail on its weakest point. Anyway, I think we are complete. So you can see it goes up and down nicely. It is designed so in its most upright position that it is there, the bolts are stopping it going any higher, so we haven't lost any travel. And if you removed your honeycomb bed and you're not using the two screws at the bottom, let's just do that, you're going to have a lot more travel in the opposite direction because that's how it's been designed. So when you're moving your laser, always move it slowly, and that's going to have to go further back. So that's pretty much it. I've got my short legs on. If you haven't seen my thin leg video, I'd recommend you go and see that, because I'm waiting to put those back on, because it makes life so much easier being able to load your material in from the front, and being able to get your make your honeycomb in and out so much easier. So let's just see how far this goes down. It should. I can't really check where the two screws are, because I've got my smooth slider there. Now that's as long as my bolt, so that's given me, how can I measure that? Well, the bolt is level with the nut. So if I wind it all the way up and then measure what length of bolt we've got, that's the travel, and this was the longest bolt I could find in this size. In a second it's going to trap on the bottom bolts. There. So the way I designed this top securing bracket, can't really see that. The way I designed this top securing bracket is when you can see daylight between the securing bracket and the bottom piece of the top bracket, you're 1 or 2 millimeters away from bottoming out on the bottom bolts. So that's just a warning, visual warning, that don't go any much further. Now it's stopped there, so that's half, 1, 1.5, sort of 2 turns. So when you see the gap diminishing here, you've then got 2 turns of the knob until the bolts at the bottom, the bolts here, stop it going up any further. So that's why I reduced the height of these, because these were a lot taller at one point. What else can I tell you about it? Nothing really. That is the fine focus. Oh yes, we were going to measure the height, weren't we? About 44 millimeters of travel. So if someone can post in the comments what travel, so I've just measured this bolt now, it's sticking up about 45 millimeters, 44, 45. So that's the travel now on the laser head, if you haven't got the 2 bolts in. Now I could, I can't see it. I can't see my, no, I can't tell you because I can't see it. Anyway, that is the fine focus Z lifter complete. Please leave a comment down below. Well, you can't do that because this is a private video. It's only being released to the people that buy the file. So if you could drop a comment on the short, well, we'll do a video about this. So if you can drop a comment on the video that is publicly released on my YouTube channel, to tell me you've made it, tell me you hate it or you love it, tell me where you think it can be improved, because I can always alter the design files quite easily. And if you like it, tell people about it. I didn't think it was worth spending the money on an aluminium Z lifter yes, they would have smoother rails, and maybe you wouldn't have to lock your laser. Maybe you wouldn't have to lock the laser down here with a posh aluminium one, but there has to be some form of locking mechanism. Anyway, so that's it. What's next is I had a brainwave today. This is my 3D printed nozzle, and this is a cutting nozzle because it's a very small hole, and I have a variety of nozzles with different holes. So if I'm engraving, I put this one on, I reduce my air pressure. This one, I was trying to do something clever with the design, with an extra air port coming out here. I haven't done much testing, so I can't really comment on that, and this was just another design. But I am working on automatic air assist and automatic air assist when engraving, and this type of nozzle will come into play, I hope, when we're engraving. My idea is to have, tell me if I'm waffling, but I'm telling you what I'm doing. I'm going to have possibly 2 air tubes coming up into one air assist nozzle. So when you're cutting, air is only blown down the nozzle. So this is a big nozzle, so air would come out this nozzle, and I'm experimenting with these. I've got an airflow meter that I'm doing some tests with. It all gets quite involved. But the brainwave I had earlier, and the reason I had those ridges on the deep engraving, I've got a blow-off tube at the moment, I'm calling this, and I was waving this in different locations on that deep engraving, so that's why I couldn't say whether it was the material that caused it or me playing with my air tube. But what I'm thinking is, instead of having a blow-off tube when I'm engraving, because you want to reduce the pressure going out of the nozzle, because you only want pressure and volume to protect your lens. If I have another air tube coming down the front, which I can automatically open and close with some form of nozzle like this, where this part is controlled separately to the nozzle, I'm wondering whether that will help reduce the burning sensation. Like here, I was making some gears for my servo assisted air assist thing. You can see the brown staining. That's what I'm trying to get rid of, because I'm finding a 10-watt laser can't pierce the wood in one go. That's why you get the brown staining, because your air assist has got nowhere to blow the debris, so it blows it on the surface, and that's what I'm trying to reduce. Anyway, I think I've waffled on long enough. Let me know what you think about the fine focus Z-lift made by Andy Shrimpton at FlixMyswitchLaser. I'm quite happy with it. I've done many versions of this. I'll probably add it in the video that I publicly release, because like anything, once you've got your design finalised, you think it's the best ever, and why didn't you design that like that in the first place? But it's all part of R&D. Anyway, that's Andy wishing you a good afternoon. Continue to make some happy smoke, and I'll see you in the next video. And thank you for purchasing my files. That will just help me purchase some more material, some more test equipment to keep improving our hobby in diode lasers. Cheers for now.